Hello, Kelsey. This is section 6.3. We're going to get probably about halfway through this section. We'll see how far we get. I don't know, because I get windy. 6.3 is a little bit different than 6.1, 6.2. We kind of step back for a little bit and talk about, like, when we're sampling things, what's legal to happen and what's not legal to happen, okay? So we know that populations out there, whatever population we're using, it's not always like accessible to survey the entire population, nor would we want to do that because it's like a lot of work, right? So we do a sample instead, right? And what we're trying to do, and we have some tables going on your homework assignment, you've got some stuff that looks like this. What we're going to be doing is we're going to be taking some samples. We're going to be calculating some means, median, range, variance, standard deviation of that sample, right? Okay? And then we're going to be doing the same thing for the population, find the mean, median, range, variance, standard deviation, and we're going to see which ones like are similar and which ones are very different, okay? And to like make this like not a ton of work, like our whole population is only going to be like 3 numbers, right? Okay? In the broad scale of things, your population would be like millions and millions of people, right? But to make this like something that we can do in 1 or 2 days, they've only made your population like 3 numbers, okay? And we're gonna, that looking at those 3 numbers is going to be enough for me to be able to compare these things with the population things, right? And we're gonna see which ones fit. Like the average of a sample. Is that truly a good representation of the average of a population? What about the range? The range of a sample, is that going to be very similar to the range of the population? I don't know. We're going to see. So we're going to see which ones are called good estimators or unbiased estimators and which ones are biased estimators. We're going to see which ones are good and which ones are not good, right? Okay. So that's kind of where we're leading today, I guess. Looking up here at number 1 and number 2 on the very, very, very top. It says sample proportions tend to be normally distributed. When we're pulling sample data out, what we usually have happen is that the average here in the middle ends up being the highest frequency. Frequencies on the, what does frequency mean again? Like the number of times it appears. That's exactly right. Yep, MJ said it perfectly. The number of times it appears. So the sample proportion, the average is going to appear the most often when you choose a sample, okay? Then there might be some times where your sample includes one of those extreme values. So like in here, okay, in this room, let's say you guys were my population, and I choose 2 people that are like average height. Who's average in here?
Jackson's pretty average.
Jackson's pretty average height. Is he really? Are you average? Yeah, he's average height for a male, right? Everybody else in here is like tall. So Erica's average and Jackson. If I choose you, you guys are gonna be these in this group, okay? Versus if I pick somebody like, let's say I choose Caleb and Abigail over here. Like that's just gonna be 1 tick mark over in this area, right? Okay. Versus any of the average people that I choose are going to be contributing to the middle, like tallest tower, right? So there might be some times where my sample, I get like an average that's really high. Like this would be if I would choose for my sample, like Abigail and Caleb, right? Which could happen, right? I would end up with data that sits over here in this corner versus if I choose some average people, I'm going to have more stuff in this area, right? So when I'm choosing samples, depending on what samples you draw, you're going to end up with data like that, but most of the time, the frequency is going to be highest in the average, right? The mean of the sample is the same as the mean of the population. Most of the time, your mean of your sample is going to be pretty close to the average of your population, right? Yep. The mean of the sample is the same as the mean of the population. That's a pretty good estimator. All right, so example 1, here we go. Consider repeating this process. You roll a dice 5 times and find the proportion of odd numbers, okay? So let's talk about odd numbers. Odd numbers are 1, 3, 5, and that's going to happen how many times? Like what proportion of the time will I get an odd number if I roll a dice? Half of the time, right? Okay, so an odd number should be 1/2 of the time. The other half of the time I get an even number, right? Half of the time I should get an odd number, okay? But let's say I roll the dice 5 times. The first time I get a 3, the second time I get a 5, then I get a 3 again, then I get a 4, and then I get a 1. Okay, I rolled the dice 5 times. Let's say in theory, that's what I got, right? What does that come out to be? Odd-wise. 4 out of 5, which is 80%, right? That's not 50%. So in that case, I would have a scenario that goes over here in this corner. Does that make sense? So not always will I end up average half and half, right? I might end up with data that's over here, but most of the time, if I roll a dice 5 times, I should end up with about 50-50, right? 50% of the time, I should end up getting an odd number, etc., right? Good? Makes sense? Something like that, okay? So we're just looking at samples versus populations, what you can get, okay? Let's see. These are the formulas that we're going to use to find standard deviation and variance. When we're doing small samples, it's actually pretty easy. We've dealt with these formulas before. I'm going to write these down here later on. Should we do it right now? Go on to the back side and I'm going to write these formulas down. Okay? So, just so that we can have them. I should have put them on the back. This is standard deviation. And this is variance. So we want to write those down. Variance and standard deviation. Okay. The sum of all the x minus mu's squared divided by n. The sum of all the x minus mu's squared divided by n. Okay. Now, just like we know already, what's variance and standard deviation have to do with each other? If you have the variance, you just have to take the square root to find the standard deviation. If you have the standard deviation, you square it to find the variance, right? They're just a square versus a square root. Make sense? Okay, so that's the formula that we're going to use down below to find variance and standard deviation. And because we're only doing a few numbers, that's going to actually be a pretty easy formula to do. Okay? All right. Ready? Yeah. Did you get your notebook back? Did you get your phone back? Mm-hmm. Yeah, it's sitting right there. Okay. You left it in here on Friday. You did. So they said that India left her phone in Mr. Brown's room first period. And so I said, "Oh, hey, by the way, when she comes and gets it, tell her to take this to Michelle because I knew you were in the same spot." But I don't know if that actually happened. No? Okay. All right. So anyway. Okay. So here's the deal. A friend of an author has 3 children that are ages 4, 5, and 9. Okay? And we're talking about ages of kids that are 4, 5, and 9. Let's consider the population consisting of 4-year-olds, 5-year-olds, 9-year-olds. Okay? We don't usually know all the values in a population, and we don't usually work with such a small population. I just said that, right? But for simplicity's sake and for wanting to get this problem done in one day, we're going to work with a population that is 4, 5, 9. Just those 3 numbers. Okay? I'm going to write that down over here. Population equals 4, 5, 9. That's what my entire population is. Normally we don't have such a small population, but we have 4-year-olds, 5-year-olds, 9-year-olds. Okay? All right. Part A, identify the list of possible samples that we could choose. That's what Part A says. You guys will have these same steps when you do your homework assignment. So if you are struggling and you're not knowing what we're doing as we go through this, please ask, because you do this exact same thing on your homework. Part A, identify the list of possible samples and write them in the table below. Okay? So if I'm sampling 2 out of this group of 3, one of the things I could do is I could get a 4-year-old and a 5-year-old. Do you see how I'm doing this? Okay, what's another grouping that I could get? A 5-year-old and a 9-year-old. A 4-year-old and a 9-year-old. Yes. Now, we're assuming that your population does have multiple 4-year-olds, multiple 5-year-olds, multiple 9-year-olds. We're just not listing them more than once, right? So this is just saying, you know, whatever. We've got multiple 4-year-olds, so you can choose a 4 twice. You could choose a 5 twice, and you could choose a 9 twice. And that is the list of all combinations of samples that you could get, right? We understand that 4, 5 is the same sample as 5, 4 if you flip it around, right? You just have those 2 because it doesn't matter what order I choose them in, they're both in my sample, right? Okay, so keeping in mind that if you flip them, it's okay. All right, we want to find the average. We want to find the median. We want to find the range. Then we're going to do variance and standard deviation, okay? Here we go. If you find the average of these 2 numbers, what is that? 4.5 is the mean. Okay, let's just do all the means. 5 and 9, what's the average of 5 and 9? 7. What's the average of 4 and 9? 6.5. The average of 4 and 4 is 4. The average of 5 and 5 is 5. The average of 9 and 9 is 9, right? You add them together and divide by 2, or just split the difference, right? Okay? All right. Let's just wait on average. Somebody can calculate that if you want to, but we're going to do the average of all of those. We're going to do that for every single one of these values going across, but we'll wait for that here in just a second. The median. What does the median mean? The middle number, right? We only have 2 numbers, so we're finding the middle. Right? The middle of those 2 numbers. So it's going to be the same as the mean, right? In the mean, you are finding the average, or the middle of the 2 numbers. So your median list is going to be exactly the same as your mean list over here. 4.5, 7, 6.5, 4, 5, and 9. Do you guys understand why that is? Yep. Because you have 2 numbers, your mean and your median are going to be the same. Okay, then range. What's the range of 4 and 5? 1, right? It's like the distance between them. 5 and 9 is 4. 4 and 9 is 5. 4 and 4, 0, 5 and 5, 0, 9 and 9, 0. Any questions so far? We're doing okay? Okay, now we have to find the variance, okay? Here's the variance. I'm going to write the formula just right here again. It is the sum of all the x minus mu's squared divided by n, okay? And we're going to fill some stuff in here. X is our number, but I only have 2 numbers, right? My numbers are 4 and 5 for the first set, right? So I have 2 numbers, and I'm just going to add them together, okay? So for the variance of the first one, I do 4 minus, what's mu? The mean. What's the mean of the first set? 4.5. I square that, and then I divide by what's n? The number in the sample. Okay? 2. I divide by 2, right? There's 2 numbers, right? I divide by 2. And I need to add that 2 because they're saying the sum of, I do that same thing again, but for my second number, which is 5. We just do those 2 things, and then we add them together, and that's it for the variance. Okay? We'll do the whole variance list, and then we'll figure out the standard deviation. What? The 5 is the second number. So 4 and 5 are my 2 numbers, right? Okay. And the formula says we take each x and we subtract the mean, and the mean is 4.5, and then we add them together. Okay? Mm-hmm. 4 minus 4.5 squared over 2 plus, you got 0.25 for the whole thing? Divided by 2. 0.25, yep, that's what I got too. 0.25 was what we got for the variance, okay? The second one, same formula again, kind of. My 2 numbers are, do we do 4 and 9? Okay, so the first one we do 4 minus, but what's the average this time? 6.5 plus 9 minus 6.5 squared all over 2. Okay, that's the second one that we do. So, and I got like 6.25. Somebody see if you get the same as me. I don't know if that's right. I got 6.25 for a variance.
Wait, why is it 6.5?
Are you supposed to do 5 in the
Why is it
first
supposed
one?
to be 7?
Ah! Who told me 6.5? Good call. Okay.
You're welcome, guys.
That's the next one.
Thanks, MJ.
I should have
After
known.
the Abby and 5-9.
MJ's a hero.
And one needs to be
What?
5 and
No,
9.
because aren't we on the second one?
The 7 goes with 5.
Yeah,
You're doing 5.
Seven
Oh,
goes-
oh, so 6.25. I did do it right. We did it right. It's just I did the third one instead. Huh. right? See, it's fine. Okay, we just got to do the second one now. Okay, we're fine. We're fine.
That 7 should go away now.
What?
That 7 over there should go.
Hold on. This way a second. 6.25 we did correctly. But this should be 5 minus 7 and 9 minus 7, right? Yeah, we're okay. We're okay.
I stuck it in for like 2 seconds. Not even. Was it?
Okay, I got 4. Did anybody else get 4?
Yep.
Yeah? Okay.
That's what I got.
Okay. Okay, now, next, the next 3 problems, we're doing 4 minus, the average is 4 squared divided by 2 plus another 4 minus 4 squared divided by 2. What's 4 minus 4? 0. 0 divided by 2 is 0. Plus 0 divided by 2 is 0. So the variance here is 0. What about 5 and 5? 0. What about 6 and 6? Why are they 0 for a variance? If you have 4 and 4, it's not varying at all, right? Variance is how much it varies. If you have 2 numbers that are the same, you have no variance. They're not varying at all, okay? If you take the square root of 0, it is 0, 0, 0. Standard deviation will be 0, okay? So for this standard deviation, the top one, we take the square root of 0.25. We take the square root of 4, and we take the square root of 6.25. I can do the middle one. Ha. 2. 0.5?
Yeah.
Yeah. And then 2.5 for the other one. Yeah?
2.5.
Yeah. Because 25 times 25 is 625, so it'd be like 2.5. Got it. Look at that. We're just so smart. Okay, so we've got those numbers. Woo! Okay, we're going to do this. And we're going to find the average of each column, and then we're going to compare it to the entire population and see if it's, like, close, right?
Yep.
All right. The mean, if we average these numbers together, all of them. Did anybody do that yet? There are 6 numbers. Add them all together and divide by 6.
Mean 6 and median 6.
Is it? Really? You added them all up and divided by 6?
Yeah.
Are you sure?
Yeah, that's what
What?
I'm positive.
6 and 6. There you go. Okay. Okay. And you add the median up, right? You don't really have to do the median because it's going to be the same number, right? The range, if you add those up and still
1.6.
divide by 6, right? Even though those are zeros, you don't divide by 3 now. You still divide by 6. So 145, that is 10 divided by 6, which is 1.6. We'll go 1.67, something like that. Variance, if we add those, 6.5 plus 4 is 10.5 divided by 6. I don't know, a little bit more than 1.67. 1.75, perfect. And the other ones would be 5 divided by 6, which is, I don't remember.
Whatever.
0.87, 0.83 repeating?
Yeah.
Yep, 0.83 repeating. We'll just go 83. Okay, so those are the numbers we get. Do we understand what we're doing? Okay? Now, here's the deal. Before we move on, you're like, why are we doing this crap? Right? Yeah, exactly. There are people who who conduct studies, right? Okay, so like they conduct studies and they gather data and they try to come out with conclusions. And then there are other people behind the scenes who are not paid probably near as much, don't get their names in the fancy papers, that are checking this information to make sure that the data that we collected in this study is close to what it would actually be if we did the entire population. Okay? So these are like the poorly paid, not so famous people. This is their busy work that they have to do. Still important, but these are like the behind the scenes checking to make sure that these come out nice, okay? So there's kind of how that works. All right. So we're going to go through and we're going to put all of this information right here in the sample column, okay? All the stuff in the sample column. So mean, we got 6. Median, we got 6. Range, we got 1.67. Variance, we got 1.75. And standard deviation, 0.83. Okay, now, we are going to do one more calculation for all of those. That includes the entire population, right? The entire population was 459. So we're going to find the mean of that whole population. We're going to find the median of that whole population. We're going to find the range of that whole population. Make sense? Okay, if I find the average, 459, I'm pretty sure it's 6. Yeah. You add them up to divide by 3, right? 6. The median, what's the median? The middle number is 5 in that case. Not quite the same. Anyway, the range from highest to lowest is 5. Wow, that one's way off, right? Is that one way off? Okay, the variance. Let's do our calculation for variance. So we take each one of these guys, 4 minus something squared divided by what?
4 minus 6.
We take 5 minus something squared divided by, we take 9 minus something squared divided by, what are we dividing by each time? 3 this time instead of 2, right? Do we see how that's different? Okay, so there's that. What are we dividing by? Or what are we subtracting? 6, because that's the mean, right? That goes there. 6, 6, and the other one is 6 also. Okay, all right, so we got all this good stuff. I'm just going to do, I don't know, 4/3 on 4/3 plus 1/3 plus 3/3. No, which is 1. No, which is 3. There we go. I got 4.67.
That's what I got.
Yeah. Are you lying to me?
I know, look how my calculator.
Okay. 4.67 is what I got for a variance when you add all those together.
Oh, really?
He didn't get the right answer.
Okay, standard deviation. I got 2.16. Square root of the 4.67. Yep. So we do this process, and then the square root of that will give me the standard deviation. The square root of this guy. The square root of 4.67. Yep. So if you need to root me, I can write it in there. The square root of 4.67 equals 2.16. If you need to write that in there, you can. Okay? All right, so now we're going to identify which ones are good estimators, which ones are not good estimators. The mean. Was that a good representation? If we take the sample, is it pretty close to the population mean?
Yeah.
Yeah, pretty close. Yes. The median. 5 versus 6. The median of your sample should be about maybe the median of your population. So let's go ahead and say, let's see what they say. They say no. Because it won't always be that close. They're saying 5 and 6 is not close enough. Okay, mean is unbiased, which means that it's a good one. These are good ones. Okay, the median, they're saying 5 versus 6 is not good enough. So they're saying no. Nah. Range, 5 versus 1.67. No, and if we think about it, the range of a sample, which is a smaller set, will not be the same as the range of the whole set, right? It's going to be smaller. So range, they have range listed as a biased, which means a bad one. Okay? Now this is where it's confusing to me. Variance versus standard deviation. They're kind of like the same number to me, but they're saying variance is an unbiased one. So variance is good, but standard deviation they say is bad. Because evidently when you take the square root, it does weird things to it or something and makes it not a very good accurate number, right? Okay, so they are saying the variance, they're saying is okay. Sure. I would say in this case 4.67 is not close enough to 1.75. But they're saying variance is a good estimator most of the time. Standard deviation is a bad one. So that's a no. Okay. All right. So even though variance for our set was 4.67 and 1.75, even though that was bad, most of the time variance comes out to be good. All right. But this just shows you, even if you take 2 out of 3 numbers, like this is how your data set changes for sample and population. Good? Yes? Something of that nature? Okay. Let's go down here. Important note, the sample standard deviations do not target the population standard deviation, but The bias is relatively small. So they're saying even though standard deviation is bad, it's not a very crazy bad, right? They're saying we still can use it sometimes. So that's the important note. Standard deviation, even though it is considered to be bad, it's not a very bad, right? It's like a decently bad. So we still sometimes use it, okay? All right, so you guys have a like thing here. Ooh, a worksheet, yeah. It's got one on the front and one on the back that's like that. And yeah, there's that. That's a lot of stuff going on, okay?
No.
Boo.
I feel like we're on a TV show and something bad has happened.
All right. What time do we get out of here? 35? 35. You have 5 minutes left to do all those problems.
Oh, no.
All of them in 5 minutes.
All of them?
That was a funny joke.
And I'll let you work tomorrow.
Okay.
Okay. All right? If you work. If not, we'll start 6-4.
Okay.
I promise you. Okay? All right. Okay.
Yes.
Okay.
I agree.
Sure.
Yeah.
All right. Bye, Kelsey.